In this video, I will show you how to find the derivative of functions involving inverse trig functions like arcsine, arccosine, and arctangent. To be clear, inverse tangent, written with this -1 superscript notation, is the same thing as arctangent. Take a moment to memorize the derivatives of the first three inverse trig functions, starting with the derivative of arctangent x. The derivative of arctangent is 1 over 1 plus x squared. Next we have the derivative of arcsine. That is 1 over the square root of 1 minus x squared. You just have to memorize this. Finally, there is the derivative of arcsecant, which is 1 over the absolute value of x times the square root of x squared minus 1. So write all of those down and study them for future reference. I see that problem number 44 involves arctangent. So let's remember that the derivative of arctangent is 1 over 1 plus x squared. Before I take the derivative, I'm going to rewrite the original function slightly. The square root of x is the same thing as x to the 1/2 power. That'll make it a little bit easier to take the derivative later. So I'm going to go ahead and take the derivative now. I'm going to have to use the chain rule since I have this function inside of a function. But first I will take the derivative of the outer function. I'm taking the derivative of arctangent, and I'm getting 1 over 1 plus x squared. Because there is an inner function, instead of writing x squared, I will put parentheses squared, which leaves me somewhere to put the inner function. The inner function is x to the 1/2 power. So I'm going to put that on the inside. But according to the chain rule, I must now multiply by the derivative of the inner function. Using the power rule, the 1/2 comes to the front, I subtract 1 from the exponent, and I get the -1/2 power. So at this moment, I really have the derivative, but I need to simplify this down as far as I can, especially in case it's a multiple choice problem. I guess technically, if this were a free response question on the AP exam, I could write this down as my final answer. I could go, hey, AP grader, blam. But chances are this will be a multiple choice question, and you will need to simplify in order to match things up. Notice that when I have a power raised to a power, I multiply. So this 1/2 times 2 is a 1. So I'm going to end up with the following. So I have f prime equals, and I'm just going to have 1 plus x. All right, the 1/2 and the 2 basically cancel each other out. I'm going to put this in parentheses for a second. I have this 1 in the numerator. Now, notice this 1/2 that I have sitting right here. I'm going to go ahead and put the 2 in front of the denominator. All right, I'm basically multiplying straight across. 1 times 1 is 1, and if I multiply this denominator by 2, I can just put it in the front. But that still leaves x to the -1/2 power. You guys understand that if I have a -1/2 power, focusing on this part right here, this tells me that I can drop this down to the denominator and make 1 over x to the 1/2 power. But then down there in the denominator, I could put this back to a square root if I wanted to. So I would have 1 over the square root of x. So that's just a reminder of what I'm going to do now. So the x to the -1/2 power is going to end up in the denominator as a radical x. So this is the final answer. For the next problem, we are going to need this fact. So get this back in the front of your mind. the derivative of arcsine is 1 over the square root of 1 minus x squared. For number 48, we will take the derivative term by term. So first, the derivative of arcsine we just saw was 1 over the square root of 1 minus x squared. Now it's time for the derivative of arccosine, which I have not mentioned yet. Compare the derivative of arcsine and arccosine. Notice that they are identical except for arccosine has a negative 1 instead of a positive 1. Since these are the same except one is positive and one is negative, they will cancel each other out. And we will end up with f prime of x is equal to 0. For number 52, there's a lot going on, so let's break it down piece by piece. I'm going to start by rewriting the function a little bit. So I have 1/2 times x, and here's the first rewrite. I'm going to write this as 4 minus x squared to the 1/2 power instead of using the root. And I will do one more minor alteration. I will write x over 2 as 1/2 x. So now I think we are ready to take the derivative sort of term by term. When you have a constant out in front, you're allowed to just leave the constant alone and go ahead and take the derivative of everything else term by term. Focus on this product. Hint, hint, I'm going to use the product rule. So for the product rule, I take the derivative of the first factor, which is 1, and I leave the second factor alone. So I have 4 minus x squared to the 1/2 power. But then I put a plus and I go through it again. The second time through, I leave the first factor alone, and then I take the derivative of the second factor. However, the second factor is going to require the chain rule. So so focus your eyes on this part. I'm doing the power rule, so the 1/2 is going to come to the front. I am decreasing this by 1, so I will have negative 1/2. And then on the inside, we have the 4 minus x squared. So the chain rule demands that I now multiply by the derivative of the inner function, which is going to be negative 2. The derivative of a constant is 0, so ignore that. But the 2 comes into the front and becomes negative 2x. Everything we have so far is the derivative of this first term. But now it's time to take the derivative of the second term. So here we go. The 4 is just going to sit there in the front. So I'm going to go ahead and put this plus 4. That's allowed to just sit there. I'm going to now do the derivative of the arcsine part. This is going to require the chain rule. But please remember this memorized fact. The derivative of arcsine x is 1 over the square root of 1 minus x squared. You just simply have to memorize that. So that's coming into play right here. So I'm going to have 1 over the square root of 1 minus. Instead of x squared, I'm going to put parentheses squared because we do have a function inside of here. So I'm going to go ahead and put that function in now. So I will have 1/2 x here. But because I do have a function inside of the function, the chain rule demands I now multiply by the derivative of that inner function. The derivative of 1/2 x is 1/2. This long, ugly expression is the derivative, except it doesn't even all fit on the screen. There's actually a 1/2 in the front off screen to the left. But we are required to simplify this one. If this were the AP exam and this were somehow just a free response question and this is all they wanted, you would be allowed to leave your answer in this form.
But usually you have to go forward and you need to simplify it in order to either answer a multiple choice question or find some other value. So let's go ahead and write down the 4 minus x squared to the 1/2 power. I am forgetting about the little 1 in front that I don't need. I think I can go ahead and squeeze in the 1/2 that belongs here now. What else do we have going on? Let's look at this middle term. So I see that we have a 1/2 and a 2. Those are going to cancel each other out. The negative sign still remains. So I'm going to erase this plus sign and put a negative sign instead. Okay, so the 1/2 and the 2 are gone. I still have an x times x, so that's going to be x squared. And then that's it except for the 4 minus x squared to the negative 1/2 power. So that's as much as we can simplify the middle term. Okay, what about the third term? I see the 4 and the 1/2. So that, if you multiply those, you get 2. I'm going to go ahead and put that 2 in the numerator of this fraction. So I'll have 2 over the square root of 1 minus, and 1/2 squared is 1/4, and then we will just have x squared. I would love to be able to simplify this by somehow taking out a GCF. And I'm seeing that we have a factor of 4 minus x squared here, and then we have another one on the middle term. We're so close. But then on the third term, not quite. This does not quite match the other two. If there was a way that I could get this third expression to be 4 minus x squared, then I would have a common factor that I could pull out. Think about this. If I could somehow multiply by 4 and have it distribute through here, what would happen? Well, then I would get 4 minus, and then 4 times 1/4 would cancel out, so I would have 4 minus x squared, and I would have my common factor. But I cannot simply multiply by 4 over 4. Obviously, we have to do the same thing in the numerator and the denominator. But the problem is this is a square root, and then this is not. So if I tried to multiply by 4, it would just end up in the front like that. In order to allow it to go inside the radical, what you need to do is put that 4 that you're multiplying by under a radical itself. Okay, I mean, think about it this way as a little mini lesson. If I try to do 2 times radical 3, there's nothing I can do with that. I'm stuck. But if I do radical 2 times radical 3, then I can turn that into radical 6. So as long as they are both radicals, I can go ahead and multiply them together. So that's what I'm doing here. I want to multiply everything by 4, but they both need to be radicals so I can go ahead and do the multiplication. So that's why I will multiply by radical 4 over radical 4. Now, when I multiply these together, the 4 will distribute the way I described, and I will end up with 4 minus x squared. Let's be careful of one little thing, though. What about the numerator, where I have 2 times radical 4? Of course, the square root of 4 is 2, so this is really 2 times 2. So I'm going to have a 4 in the numerator. So we now have our common factor, but I need to get it all on the same level, I guess I would say. These are all on one line, but this is kind of in the denominator. So what I'm going to do is I'm going to rewrite this as a 1/2 power. And because it's in the denominator and I want to bring it up, then it's going to end up being the negative 1/2 power when I write it all out. So that's the change I'm about to make. So now everything is all on one level, and I have a common factor of 4 minus x squared in all three terms. So I am ready to take that common factor and put it out in the front where the 1/2 is. So I'm going to have f prime is equal to 1/2 times 4 minus x squared. I have to decide what exponent I'm going to use for my GCF. And of course, I'm going to go with the lowest exponent. That's what we always do. But the lowest power is negative 1/2. So I'm going to bring out a 4 minus x squared to the negative 1/2 power. So when you bring out a GCF, you are really dividing by the GCF, all three terms, and that's how you know what goes on the inside. When you divide by a base and a power, you subtract the exponent. So I really need to subtract negative 1/2, but minus and negative is addition. So really, I'm going to end up adding 1/2 to all of these powers. Okay, so on this first term, 1/2 plus 1/2 is a whole. So I don't need to write that exponent at all. So I'm going to end up with 4 minus x squared to the 1 power, which I don't write. For the middle term, I'm taking out 4 minus x squared to the negative 1/2 power, which is exactly what you see here. So this entire factor is just gone. Another way you can look at it is negative 1/2 plus 1/2 is 0, and the 0 power turns all this into a 1. And you could think of it that way, and that's why I'm not writing it. Whatever makes you happy. So this is gone, and I just have the x squared. So now I'm moving on to the third term. Wait, it's another x squared. So this, I have my 4 minus x squared, which came from right here. But now I have this minus x squared as well. So I'm going to go ahead and bring that down for the middle term. And now I'm moving on to the third term. So I'm going to have this plus 4. And again, we have taken this entire factor away. That's the GCF that we see right here. So that is now gone, and that's the end of pulling out the GCF. We have some like terms to combine. So let's get to it. I have my 1/2 4 minus x squared to the negative 1/2 power. I think I'm going to use regular parentheses now. 4 plus 4 is 8. So I have my 8. And then negative x squared minus x squared is negative 2x squared. So I have this. Okay, I'm kind of running out of space. I'm going to squeeze one more line in here. So I have f prime equals. I see a GCF in here, a GCF of 2. So I'm going to take that 2 out and put it in the front. But you know, if I pull the 2 out here, it's going to cancel out the 1/2. So just understand that I am taking out a GCF of 2. It's going to wipe out the 1/2. So I'm going to end up with 4 minus x squared to the negative 1/2 power. Now I've taken out a GCF of 2, so I'm going to be left with 4 minus x squared. But look what just happened. We've now created another factor of 4 minus x squared. So these now match. So we have the same base, except for the first one has an exponent of negative 1/2, and the second one has an exponent of 1. So think about how you handle it whenever you have like bases, right? So like if I have n to the third power times n to the fourth power, that is n to the seventh power. I simply add the exponents. This is fancier, but it's going to work the same way. I have the common base that I'm multiplying. So I'm going to keep that common base of 4 minus x squared, but I'm going to add the exponents. So this is going to be negative 1/2 plus 1 is 1/2. And we know that the 1/2 power is the same as the square root. So we could write this as f prime is equal to the square root of 4 minus x squared. And this is the completely simplified version that you would find on a multiple choice option. I know that was a lot, and this next one is very similar, so I encourage you to pause the video and try to do this one by yourself, and then play the video and see how you did. Let me go ahead and rewrite this a little bit first. Maybe I'll just leave this as x over 5 minus x times 25 minus x squared to the 1/2 power. All right, that's just the only rewrite I'm going to do. Now let's do the derivative. Y equals. I'm going to ignore the 25 for a second. We have learned that the derivative of arcsin is 1 over the square root of 1 minus x squared. But instead of putting an x, I'm going to put parentheses because I see that we have a function inside of this function. So on the inside, I'm going to put x over 5. And that reminds me that I need to do the chain rule and multiply it by the derivative of the inner function, which would simply be 1/5. Now, don't forget about the 25 that was in the front. This 25 should end up in the numerator, because this is like 25 over 1, I guess, if you need to think of it that way. So I am going to put the 25 in the numerator. So I have this so far. Now I'm going to move on to the second term. The second term is a product, so I'm going to use the product rule. Notice how I'm including the negative sign in the first factor. You don't have to do it that way. You could put a negative sign and then use a big parentheses and do the product rule without the negative sign, but then you have to take the extra step of distributing the negative sign later. So I prefer to do it this way. So I'm going to take the derivative of the first factor, which is -1, while leaving the second factor alone. So I have -1 times 25 minus x squared to the 1/2 power. And then I put a plus and I go through it again. The second time through, I leave the first factor alone. So I'm going to have negative x squared. I'm going to have negative x. I don't like putting plus minus, so I'm just going to put the negative x. And now I take the derivative of the second factor. This is going to involve the chain rule. So this 1/2 is going to come to the front. I am subtracting 1/2 from the exponent, so this will be -1/2. And then I've got the inner function, which is 25 minus x squared. So because of the chain rule, I need to multiply by the derivative of the inner function, which will be -2x. So let's go back and clean this mess up. So we're going to have y, well, you know what, this is y prime, isn't it? So we're going to have y prime equals, I see that we have 25 in the numerator, and then we have this 1/5. Let's go ahead and cancel those out. So that will leave me with 5 in the numerator over the square root of 1 minus x squared over 25. I'm just squaring x over 5. So that's it for the first term. The middle term can simply be written as 25 minus x squared to the 1/2 power. I'm just ignoring the -1. And now for the third term. I see that we have a 1/2 times a 2, so those cancel each other out. I see that we have a negative times a negative, so that's going to be a positive. And I see that we have x times x, so that will be x squared. So x squared times 25 minus x squared to the -1/2 power. So this is what we have so far. I am remembering what we did on the previous problem, and I'm noticing that we have a common factor in 2 out of 3 terms. I would love to have that same factor right here. So what would I have to do to turn this into 25 minus x squared? If I could somehow multiply this by 25 and distribute, then the 25 times 1 would become the 25 that I wanted, and the 25 would cancel out this 25, leaving the x squared that I wanted. But that doesn't work if I have a 25 times a radical. It will work if I make it a radical 25. Then I can actually multiply the two together just like I wanted. So that's why I'm going to multiply by radical 25 over radical 25. So under the radical, I will get the 25 minus x squared, just as I described. What about the numerator? Remember that this is the square root of 25, which is 5. So this will really just be 5 times 5, so I'm going to have 25. And I went ahead and just brought down everything else unchanged. So in order to get these all kind of on the same level and looking the same in terms of the common factor, I'm going to take this part, the square root of 25 minus x squared, and I'm going to rewrite it as 25 minus x squared to the -1/2 power. You know that the square root is the same thing as the 1/2 power, and it's in the denominator, so that makes it a -1/2 power once I put it all on one line. So that gives us this. It is time to factor out the common factor of 25 minus x squared. But what power are we going to use? We're going to take the lowest exponent, which is -1/2. So there's my GCF. When you factor out a GCF, you are really dividing by that common factor. And when you divide a base with an exponent, you subtract that power. So I need to subtract -1/2. And of course, minus and negative is really addition. So that's why I'm going to be adding 1/2 to all of these exponents. So for this first one, you could look at this as -1/2, +1/2, that's 0. The 0 power turns this into a 1, so it is now gone, and I just have the 25. Or you could just say, look, this is the common factor that you pulled out front. So you pulled it out front, and now it's gone. So that's why you have just the 25. Anyway, on the next one, the middle term, we have 1/2 plus 1/2. That is a whole. So I'm going to have just minus 25 minus x squared to the 1 power, which I don't even need to write. On the third term, again, you can look at this as, well, wait a minute, this is the factor, exactly what I pulled out to the front. So this entire thing is now gone, and I will just be left with x squared. Or you can look at it as a 0 power, which makes this a 1. So we can just distribute this negative sign real quick. So we get this plus x squared now, and we combine like terms. So I'm going to bring down my y prime is equal to 25 minus x squared to the negative 1/2 power. 25 minus 25 is 0, so that's gone. X squared plus x squared is 2x squared. For the last step, y prime equals, I am going to leave the 2x squared in the numerator. As I drop this factor down to the denominator because it has the negative exponent. So that would give me 25 minus x squared to the positive 1/2 power. But we know that the 1/2 power is the square root. So better to go ahead and write it as the square root of 25 minus x squared. So this is the final answer.